Today we're going to talk about how to find the volume of prisms and cylinders. The volume, to be able to do this, we have to understand what the volume is. The volume is the number of cubic units contained in a solid interior. Well, so far all we've talked about is like area or the perimeter of objects. So if we have the perimeter of a square, you just go base times height. But now we look for the volume. We're looking for the 3D version of this. Okay? It's going to look something like that. So now we're looking at 3D shapes to find volume. Volume is the total number of units that would fit inside a prism or cylinder. So, here's some postulates we need to know. The volume of a cubic postulate. So the volume of a cube is the product of the length of sides. Or in other words, then this only works for cubes, is if you find the side length, you can use this equation. Volume equals the length of the side cubed. We also need to know the volume congruence postulate. If two polyhedra are congruent, then they have the same volume. We also need the volume addition postulate. The volume of a solid is the sum of the volumes of all its non-overlapping parts. So if we have a little bit of a strange part, we can break it, a strange polyhedra, then we can break it into different parts and find the volume for each part and add it together to find the total volume. Here's kind of an example of that. This one wants to find the volume of the puzzle pieces in cubic units. Now if we look here, we can see that each cubic unit is a 1 by 1 by 1, so they are cubes. So in that case, we can find the volume of cubes equals the side lengths cubed. Well, we know the side lengths of each one of these is 1, so 1 cubed really is going to be the answer. So we'd say 1 unit cubed for each one of these units. Now if we look at the puzzle, we have to find out how many units there are. What I'm going to do is break that down into pieces. I'm going to look at this piece first. On this side, there's 2 going up, there's 2 going sideways, and then there's 2 going deep. Okay? So to be able to find that, how many total units there are, I'd go 2 times 2 times 2, which equals 8. There's 8 units there. Now let's look at this section here. This, from here to here, we have 1, 2, 3, 4. Up we have 1, and deep we have 2. So that would be 4 times 2 times 1, which equals, again, 8. So there's 8 units in that section. And lastly, we have this section. And we have a 1, we have a 2 high, and we have it 2 deep. So this would be 2 times 1, which equals 4. Now if we add all those together, we get 8 plus 8 is 16, plus 4 is 20 units. So our answer is going to be 20 units cubed. That would be the volume for that puzzle. So if we're looking at just prisms, a prism is a solid figure whose bases or ends have the same size and shape and are parallel to one another. And each of those sides is a parallelogram. So here's the theorem. The volume of a prism is the volume equals big B times H. Now this big B is important. It means big B means the area of the base. So far we've mostly talked about little b. We talked about area equals little b times height. You really need to distinguish the difference between a little b and a big B. The little b means the area of the base. Or the little b means the base or the length of the base. Big B means the area of the base. Okay, and height is still height. H is still height. Went wrong way. So here's kind of also we need to know about what a cylinder is. Okay, it actually has the same volume. Volume equals big B times H. But we need to understand that big B again is the area of the base. So with a cylinder, you have to find the area of a circle. And to find the area of a circle, you use this equation, pi r squared. So you could change this for a cylinder. You could say volume equals pi r squared times height. And really, if you think of it this way, it's the easiest way to remember how to do the volume of a cylinder. Alright, here's how you would find the volume of this solid. Now again, volume for a prism is volume equals big BH. Now in this case, big B is going to equal the area of a trapezoid. Okay? So the area of a trapezoid is little b, or the height, sorry, times base 1 plus base 2 divided by 2. Okay, so that leaves us with the equation, the volume equals, now our height for the trapezoid is 3, right here. I'm going to say my base 1 is 14, plus 6 is my other base up here. And then the height of my prism is down here, it's 5. I'm going to put it here. Make sure we divide this all by 2, right there. Okay. Now if we punch this into our calculator, this is going to be 20 times 3, which is 60, divided by 2 is 30, times 5 equals 150 meters cubed. That would be our volume. Alright, let's look at the next one. So here is a cylinder. Again, we're going to say the volume for a cylinder equals big BH, or we can say the volume equals pi r squared h. Okay, and height again is the height of the prism, or the 6 foot over here. So we could put this in as pi. Now our radius is 9, so we put 9 squared times the height, which is 6. Okay, 9 squared is 81, pi times 6. Now I'm going to punch this in my calculator really fast. And I get 150.72 feet cubed, and that would be the volume. Okay, and always your volume is going to have it cubed. That's just part of it. Now let's look at the volume of this cube. Now, in this case, it tells us the volume and wants us to find lengths of the side. Now we know the volume of cubed equals the side lengths cubed. So if we know volume, we can say 90 equals x is our side length cubed. Now to do this, we'd have to take the cubed root of both sides. And we'd have the cubed root of 90 equals what? Now in this case, you're going to have to type this in your calculator. There's a couple ways to do it. On my calculator, there's a little button that looks like this, x with the cube. And what you have to do is hit 3, and then hit this button, and then you put 90 underneath. And when you do that, I got 4.48, and that would be not cubed, that would just be in inches. That would be your answer. The other way you could do this is to convert this to a fractional power, which again, how you do that, you'd say 90, put a little fraction sign up here, and the power, whatever power is under the radical goes on top, and then the index, or the number that tells you what root you're taking, you put underneath. And you could punch it into your calculator like 90 with your little power sign, parentheses 1 divided by 3, and again it would give you this answer. So there's a couple different ways you can do it. If you have any questions, please get a hold of me on how to put that in your calculator. Alright, Cavalari's principle. If two solids have the same height and the same cross-section area at every level, then they have the same volume. Or in this case, a right circular cylinder, which is what we normally deal with, that has the same height as a oblique cylinder with an altitude that's the same height or the same length, then they're going to be equal. So in this case, it wants us to find the volume of this oblique cylinder. Again, you're going to use the same formula. Volume equals big BH, or in this case, volume equals pi times the radius squared times the height of the cylinder. Now we know the height is 7. We know the radius is 4. So we just say pi times 4 squared times 7 equals, just punch that in your calculator, and you get 351.68 centimeters squared. And that is really it for this lesson.